In this exercise we'll be using digital multimeters to measure resistance, voltage and current. We'll start off by using the digital multimeter to make a very simple resistance measurement. Firstly, we can turn the multimeter on. First setting, the V with the horizontal bar is for DC voltage. Second setting, the V with the AC symbol is for AC voltage. And the third setting, the one with the omega or resistance symbol for resistance measurement, is the one we want. We've currently got nothing plugged into it. The resistance and the input is effectively infinite, and so it's displaying overload, and the little mega ohm symbol is up there as well, so it's more than 1000 mega ohms. So this this digital multimeter is seeing nothing. Let's plug some probe leads in. The test lead, or the positive lead, goes into the red input, and very importantly, for almost all measurements, the other lead goes into the common input. On this particular multimeter, that input, the third input, is only used for the 10 amp current measurement. All other measurement inputs are those two inputs. Now, here we have a resistor we want to measure. It's clamped in a mounting block for convenience. Measuring resistance could be as simple as just holding the probe leads. Actually, it doesn't matter which way around we do things for measuring resistance, but I'll be just holding the probe leads against there, giving it a few moments to make a resistance measurement. It's coming up and it's saying that is 55.9 or 55.8 ohms, wandering around a bit. We put these things in a small mounting block to make it just a little bit easier for steady measurements, so I can just clamp that there, and just leave it for a few moments until it makes its measurement. And it's coming up as 55.7 ohms. Wandering around a little bit as time goes by. So there is some uncertainty in that meter. We'll discuss that in a moment. Just having a look at the resistance we're measuring, let's have a close look at that resistor. On the resistor there are some colour bands that we can read, and if we look closely at those colour bands you may just be able to see green, blue, black, a space and then gold. So you look for the colour bands on the resistor. Where there is a space, you put that to the right, and then you read from left to right. Green is 5, blue is 6, black is 0, and gold is 5%. And so the first two are digits, 5 and 6. The third one is a multiplier. 0 means no zeros, or 10 to the power 0, so that is just 5, 6 or 56 ohms. Just looking quickly at your lab manual, you'll actually be measuring the resistance of a 10 kilo ohm resistor using a number of different methods. We've actually measured a resistor which had a nominal value of 56 ohms plus or minus 5%. 56. Now 5% of 56 ohms is in fact 2.8 ohms. So the nominal value of the resistor we just measured was 56.0 plus or minus 2.8 ohms. Now what we actually measured was 55.7 ohms. How good is that number? To know the precision of a digital meter of any sort, you have to consult the manufacturer's specifications or manufacturer's manual. For this particular multimeter, on resistance ranges, it's rated at plus or minus 0.8% plus 2 digits. Now 0.8% of 55.7 is actually 0.4456. However, it makes no sense to quote any digits past the limit of measurement of the instrument, and so we'll round up to the nearest whole digit there, or the one decimal place. Plus or minus 2 digits refers to the fact that there is often a round-off error in analog to digital conversion, and in this case it suggests the round-off error is a 2 in the last column. So that's what 2 digits means. It simply means the numeral 2 in the last column. So plus or minus 0.4 due to the precision of the electrical instrument, plus or minus 0.2 due to analog to digital round-off error, gives us a total of 0.6. So what we've actually measured is 55.7 plus or minus 0.6 ohms. So that's quite acceptable. The actual measured value of the resistance falls well within the nominal value.